Right. Good morning. 6.1 trigonometric identity. Show, verify an equation, given equation using trig functions is valid or invalid. That was our topic yesterday. Basically what we do is you pick one side, either left or right. You pick the side with more potential, more complicated usually, and it has room for cancellations, additions, subtractions. You pretty much use the identities you know from previous sections, all these reciprocal identities, Pythagorean identities, even odd identities. And also you use some tricks you know from college algebra, basic algebra, like getting common denominators, multiplying top and bottom by conjugate, or simply multiplying, sometimes factoring, and get the left side meet the right side. That's it. Okay, I think last thing we did was number 5. We're gonna take a look at number 6. Pick a side and work. So I'll give you 2 minutes to think about this one. Yes, which side did you pick? Which side would you wanna work on? Left or right? Right? Okay, seems like the right one is tempting. It has more juice, more crowded, more squares there. I don't know, maybe you can go from that side, but I was thinking the left side. But not right, maybe we'll go and figure out the right side. What tricks can you apply here? Here are your tools on the right, and you know the basic algebra tools. Look, look where you're going. You need to make this, right? And it at the end. I need to do some work, get this out. And what I see on the left is sine and cosine, but bunch of sine and cosine, and a bunch of sine and cosine already on the right. The main difference is I don't have any square on the left. I believe this square must go somehow. There should be some cancellation then. This cosine, one of the cosines must cancel, but I don't see how they're canceling. Or can I just cancel like this? One of these with one, and there is still one left here. Can I cancel like that? No. This bunch of items is still subtracting from another term. Addition, whenever you see addition and subtraction between the term cancelled, they are not suitable for cancellations. If this was gone, these were gone, yeah, you could cancel them because everything is in product form on the top. But if there are some additions, more additions and subtractions involved, we cannot cancel it. So no cancellations happening. I need to reduce this square. My hands are tied. I can't see any tool here to reduce this square. Do you? Let me know if you know. Maybe there is a way. I'm not perfect, but I don't see it. Okay, so I'm going to quit this side. I will pick the left side. Left hand side is this. Alright, I know what to do. I need to get a square on the bottom around cosine. I need to get sine and cosine multiplied. This kind of gives me an idea. So to raise cosine into square, I think we should multiply these things with stuff. So what do you think? What do you think you should multiply? Yeah. This is a tough one. Any ideas? Okay, you're on the right path, except you said sine x plus cos x both sides. Alright. We need to multiply both sides. We can't just multiply one side because it's gonna be unfair. We need to keep the balance. So whatever you're doing to the top, you must do it to the right. But I have an objection to the sign. We must pick the opposite of this one. It's called conjugate. Let's pick the conjugate of this thing. I mean, you can try the positive first. See if this works. But I don't want to waste time trying it. I will go with the minus and this minus. This is called conjugate multiplication, common trick, okay? Why am I multiplying again? What is the need? How do I foresee that? Because I need to be getting cosine square. And I need to be getting sine and cosine multiplied. Look, if I FOIL this, I'll have somewhere sine and cosine multiplied. So these items on the right side were hints, were the guides for me. They were screaming at me, oh, you need to get squares and multiplication. Okay, multiply by conjugate then. Okay, now I need to FOIL it. First terms, outside terms, inside terms, last terms. I will FOIL the top. It's actually a difference of same items, so it's actually a square, sine x minus cosine x squared, but I will multiply and see what we get finally. Sine squared minus sine cosine. What a coincidence, you get the same item again, sine cosine again. Cosine times sine is sine cosine. And finally cosine square. I'm not going to FOIL the bottom. There is an easier way to multiply the bottom. Why? You can FOIL it. It works. Isn't this a plus b, a minus b formula? So we can just square a and square b and take a difference. So this bottom is sine square minus cosine square. Or just FOIL it and you will see the middle terms cancel each other. Outside terms sine cosine and cosine sine are the same inside and outside terms, but they are opposite sign, so they will cancel. So you instead of 4 items you will have 2, because the middle, these 2 terms here are canceling because they are opposite sign. Okay? In here on this one. Okay, I'm stuck. This is how far I go. You can pick up from here, I think.
Could you take the sine squared and then do the plus cosine squared and do equals 1?
Exactly. When you have sine squared and cosine squared together, they add to 1. Which rule says that? It's this one. So I can put those two and say 1. Alright, what do I do with these green ones? Aren't they the same? So same thing twice makes it how many? 2 sine x cosine x. Oh my god, I have already obtained the top. Good, that means I'm on the right track. I am just need to be adjusting the bottom, and I'm lost on the bottom side because this bottom is 1 minus cosine squared. This is sine squared and minus cosine squared. I believe we have to keep cosine squared because it's here. But we need to somehow lose sine squared. You need to change sine squared into something else. Ideas?
Sine squared would be 1 minus cosine squared.
Exactly. When you subtract this, put cosine squared to the other side. Look what's going on. Sine squared is 1 minus cos squared. So can I make this 1 minus cos squared here instead of this? So you have 1 minus cos squared, another cos squared, double cos squared then. So it is 1 minus 2 cos squared. That's the right hand side. Question is over. Okay. Wow, that was tricky, right? Okay, let's take a look what's coming up next. They want us to show ln of some trig functions equal to twice ln of a third type trig function. Prove that. Take a side. Use this time you need to combine properties of trig functions together with properties of what kind of function you see around them? Logarithms. Do you remember that chapter? 4.3 and 4.4, section 4.3 and 4, logarithms. We have addition law, product law, quotient law, power law, and a bunch of other laws. Go visit that section if you wish, but we need to make left just like right side. So I'm gonna give you the hint. Start with the left hand side, please. Work on this side.
Did you take the left side element tangent over cotangent?
Yes, that's called quotient law for logarithms. If you have a logarithm of u over v, we can split it as logarithm of u minus logarithm of v. We are gonna do this thing backwards here because we already have a difference of logarithms. We are gonna turn it back to a quotient. Look, difference of two logarithms like that, making it back to u over v. So this is actually ln of tangent t over cotangent t. If there is an absolute value on the numerator and denominator, actually, you can make it one common absolute value covering the entire ratio. So this is technically equal to tan t cotangent t. Well, we're almost there. I have at least one ln. I'm missing 2, and I need to reduce this to tangent. I don't see it. I can. So you want to change tangent to cotangent, but that's, yes, change cotangent to tangent. This cotangent is, because we want to make everything tangent, right? Cotangent is 1 over 10. So you guys have here a ln of 10, but 1 over 10. Okay, now I have double tens, one on the top, one on the bottom. Yeah, we can multiply both sides by tangent, so this bottom one cancel, or you can flip and multiply with the top. You can flip this and multiply with the top. Either way is fine. So when I flip 1 over tangent, it becomes just tangent and combines with the other tangent in multiplication. Now you guys almost there, except this 2 is in the wrong place. I wish it was in front. Yeah. Right. Rules of logarithm says if you have a logarithm with x to the p, any base x to the p, this is the 7th one in the list back then, p goes in front and stuff inside remains the same. However, my question is, that square should be around everything. That's absolute value. Can I move the square here and then move that there? Yes. In absolute values, powers can go in and out as they wish. So this is no problem. So you can move this to outside of the absolute value. Actually, when you have a square, you don't need an absolute value anymore. You don't need this absolute value anymore, but just put that 2 in there. And we're done. By the way, why do they keep using absolute value everywhere? Because ln only accepts positive. These should be positive, so ln can make sense. Logarithms work with only positive numbers. You cannot compute logarithm of negative numbers. So to be safe, they put absolute value around them. Because tangent can be negative sometimes. So you just, when you're operating them, you just ignore this absolute values and just do your regular algebra. Alright, this was it. This is a combination of logarithms with trig functions. And our last question here today is another identity proving technique. However, read the statement. Gives you actually, it saves you time. If you start one side and try to go to the other side, you won't be able to do so. Okay, it's too hard that way. They say take each side separately, independently, work on each side slowly, and try to meet at a common point. Look, this is what we usually were doing. This was the left-hand side. You were going from left to right. You were moving this guy to here, or sometimes you started from the no, this is right hand side. Sometimes you started with the right hand side and you moved to left. But when you meet somebody, do you expect somebody to come to your house all the time? No, sometimes you go meet at a coffee shop right in the middle. So this is an application of this case. Left hand side and right hand side both move a little bit and they meet somewhere in the middle. This is what we're gonna do. You're gonna take left hand side on this corner, right hand side on that corner, work them out and stop when they meet. When you see, oh, they match. After a while they will, and we will stop. Okay? Make sense? Okay, start working left and right separately and see if they meet somewhere in the middle. Alright, for the left side, please tell me what kind of tricks did you do? Left side. Do you see you can flip any of these into something? Ashley?
Can you show me the top one secant?
Right. 1 plus 10 squared is secant squared. Yep, I can make it secant squared on the top. And secant squared over 10. Alright, it's turn for the right side. Every two people are meeting, right? So let the right side take a step now. We took a step on the left, let's take our step on the right. What do you want to do here? No ideas? Do you see something coming on the bottom? Sine and sine cube. Remember, cubes are useless. Sine cube, we have no identity about cubes. So I wish there is a way I can reduce this cube to square. Yeah, we can factor a sine out from them. Oh my god, look how beautiful this thing is now. Okay, take another step on this side, please. Come on. What do you want to flip here? Just take a chance and flip something. Everything here is sine and cosine, and this is secant tangent. They don't align. You can't work with secant and tangents. Here is cosine and sines. So what do you feel like doing?
Change secant into 1 over cosine.
Right, secant is 1 over cosine. So secant squared is 1 over cosine squared x. Can I change tangent as well into sine over cosine? Well, this is a single ratio. This is a ratio and a ratio and ratio, triple ratio. This is called a complex ratio. Can I flip this and multiply with the top so they can combine? They combine into 1 over cosine squared x cos x sine x. And it becomes cos x cosine squared x sine x. Agree? Alright, this guy took 3 steps. It's not fair. Let's move on this side.
One minus sine squared x is cosine squared.
Great. Again, back to Pythagorean identities. Subtract sine squared now from both sides. Cosine squared is 1 minus sine squared. Cosine, keep that in mind. Cosine squared is 1 minus sine squared. So this thing is cosine squared. Oh my god, look what happened. Did we meet? Did they meet each other? Yes. Well, you can even simplify more and see better. These are cancelling. So it's 1 over cos x sine x. Oh look, these are cancelling as well. So it is 1 over cos x sine x. It's a match. That means it's an identity. This equation is correct. Okay? You could have stopped here because it's a match here as well. I just wanted to simplify more. You can actually turn this more. 1 over sine x is cosecant over cosine. Right? 1 over sine x. But it's not necessary. They just want us to match with it. Okay? Alright, you don't have to figure out this on your own, I think, in some questions. I didn't try any of these questions, but what's beautiful about Connect Math is they direct you into the right path with step-by-step moves. No, this is wrong, sorry. It's wrong assignment. Still in 6.1. Yeah, they do in 7 parts. They tell you in each part kind of which part you need to change. They say 1 plus tangent square becomes. You need to figure this out on your own, but you need to work on the top and make this secant square x. You're still working on what left side, and then they make already 1 over cosine square, and you just need to say which identity you used. What's this identity called? Secant square becomes 1 over cosine square. I mean, I don't even know what the correct name is. Just cheat from here if you need to. We used which one we used? Secant is 1 over cosine, right? So it's reciprocal identity. Yeah, it's, I don't know why they asked a special name for it, but and they say use the quotient identity for the bottom. Tangent becomes sine over cosine. And then it says simplify, flip and multiply as I did, and put the simplified version 1 over, and that's the result. If you flip and multiply and cancel, you get 1 over cos x sine x. That's what you need to enter on the left side. And then you start working on the right side. Sine x cos x. Now you start working on the right side as I did. You factor GCF means factor what is coming in sine in the bottom. So you're gonna factor sine x as 1 minus cos, no, sine square x. And then you replace 1 minus sine square as cosine square. So you need to go with their own steps. Unfortunately, you can't do your own. So that's why I didn't take this format. You're free to work on your own here. But here you need to go with their direction. Simplify, you will get the same thing, okay? And the mission accomplished. Alright. But again, my recommendation is first do this on your own independently on paper, get the identity proven, then go to this connect math and follow their directions. Maybe they have a better way or alternative way, so you kind of solve this question in 2 different ways, if there is an alternative way. Alright, but we're done with proving identities for a while, but we'll revisit them soon. We're taking a short break. We're gonna learn more formulas, more toolbars, and then we will start applying them into proving identities again. So we will revisit this, but what we need to learn is how to separate addition of 2 angles under sine, cosine, and tangent. Addition and subtraction both. So it's called sum and difference formulas. See, every week we are adding a new table, new rules, identities into our toolbox. So my recommendation is start building your cheat sheet or formula sheet. Every week keep adding these, bring it to class, and when you're working on questions, you don't have to flip the pages to find the right stuff. Or everything on one page is even better, okay? Now, why do we need these new rules? Because sometimes you need to compute an angle, but you can't do it with a calculator, but you know it splits into 2 smaller angles. You know very well it's sine and cosine. So you're wondering, is there a way to split an angle into 2 pieces? Yes, but it's not this way explained on the top. Look, what they did here is they broke 60 into 30 plus 30, and they computed sine 30 and sine 30 separately and got 1. But we all know that sine 60 is not 1. It's root 3 over 2. It's about 0.8 something, I believe. 0.9. So you see, obviously they are different. So what lesson we got here is sine 60 is not addition of sine 30 and 30. Unfortunately, now I wish it was that simple. Then what is the right way to break it down? I need to break 60 into smaller pieces, smaller angles. Here is the right way. 60, sine 60, or any 2 angles can be broken out in terms of sine, cosine, cosine, sine, addition. So you take the sine of the first angle, cosine of the second. This is how you memorize. Sine of first, cosine second, plus cosine of first, sine of second. and then cosine of first, sine second. Again, sine of u, first angle you see here, times cosine of second angle you see, and then you flip them. Cosine of the first angle and sine of the second, and whatever this sign in the middle is, you keep it. It's addition, so you keep addition. For subtraction, only difference is this minus comes to the middle. Same formula, sine u, cosine v. Cosine u, sine v with a minus. For cosine addition formulas, cosine of two angles is cosine of first and cosine of second, sine first, sine second, but this is minus. You see the difference? For addition, we are using subtraction. For subtraction, we are using addition. It's backwards for cosine. And besides, you have both cosines, both sines, cosines and sines on each side. I don't expect you to memorize this, so keep on the side and know where to use it and cheat from the sheet. Unfortunately, yeah, you can't memorize it, but after solving 10 questions, yeah, it will already be on your mind. Okay? Tangent. For tangent, however, it's a quotient. You get a fraction. Tangent of first and second, u and v is added up, and then you multiply u and v and subtract from 1. For subtraction, it's minus minus in both spots, but plus the multiplication of tan u, tan v. Look, I'm marking the same color, means if it is this is plus, minus, minus, and you choose the opposite on the bottoms. You first add them and then multiply them and subtract from 1. Kind of easy to memorize. Subtract, multiply, add. Now, how do we apply this? I need you to compute sine of negative pi over 2, and you think you can do that by a calculator. You don't need this stupid formula to work on. Look. Yeah, we found it. Why do we need the formula, right? Google can do this for us. Just copy this into here. And put it there. Whoa, what happened? Is Google wrong? Yeah, this number looks like ending, but it's ending because we're out of screen. We don't have room for it. This answer is never ending. It's an irrational number. It's a never-ending digits. Keep following, repeating the different pattern. So we cannot compute this with a calculator. We need an exact answer with radicals, square roots, cube roots, or something. So we definitely need to know how it's done by these formulas. Okay, here's the hint. Please first change this into degree. How many degrees is pi over 12? Just multiply by 180 and divide by pi. How many degrees is that? Cancel. How many times 12 goes into 180? 15. So that's minus 15 degrees. Just think that. Is there a way do you know what sine minus 15 is from your tables? Do you know it? No, what I know is sine 30, sine 45, 60, 90, 120, 150, that wheel of values. So I have multiples of 30, 30, 60, 90, 45. I know 45, but not 15. I wish I do. Question is, can I write this 15 as a sum or difference of well-known angles so I can use the formula above? Let me repeat. Is minus 15 sum or difference of some well-known angles you know from the chart?
Minus 45.
Yeah. Sine minus pi over 12 is 30 degrees minus 45. But come on, they gave us radians. Don't use degrees. I mean, for workout here we used it. I need to flip back to radians. What is 30 in radians? Pi over 6. 45 is pi over 4. Look, you have this exact situation right here. You have sine u minus v. This is your u. This is your v. Go figure. Write the formula down. It says sine of u cosine of v minus cosine of u sine of v. Instead of u and v, you need to replace pi over 6 in these two spots, and pi over 4, v is pi over 4 in these spots. Alright, now go look at your sine cosine value chart or wheel. What is sine 30? One over cosine 45. We multiply them later. Minus cosine 30 root 3 over 2 sine 45 root 2 over 2. All we need to do is multiply these across. 1 times root 2 is root 2, 2 times 2 is 4, minus root 2 times root 3 is root 6 over 4. We can combine them, right? Which becomes root 2 minus root 6 over 4. Okay, have the common denominator, just combine like this. But can I subtract 2 and 6 and make 4? No, we cannot combine radicals like this. Radicals only combine if they have the same numbers inside. Like if this is 3 root 2 and this is 2 root 2, yeah, 3 minus 2 is 1, root 2 is the answer. So you can only subtract the numbers in front of them and repeat the common radicants inside terms. 2 and 6 are like different variables. They don't subtract. So this is our final answer. It's exact answer. Root 2 minus root 6 over 4. It is, okay? All right. Coming up next. Question number 2, this time using cosine. First, if you can't figure out what this turns into sum and difference, first change it into degree and then figure. 5 pi over 12, how many degrees is that? Again, 12 goes into 180 15 times. 5 and 15 makes 5 times 15, 75. Alright, that's 75. Can you think of two angles that adds or subtracts to 75? That's good. 15 and 16. 60. Question is, when you split these up, do you know cosine 15? No. 30, 45 is a better choice. 30 is pi over 6, 40 is pi over 4. So it's the same deal, different formula. It's this one this time, right? U plus V. So we go with cos U, cos V, cos cos, sin sin, except we have a minus. Just replace U and V now, pi over 6, pi over 4, pi over 6, pi over 4, multiply and subtract. Be careful, one of the common mistakes is just because this is plus, people take this plus. It's a minus. Okay? Cosine 30 is root 3 halves, root 2 over 2, 1 over 2, root 2 over 2. Agree? Multiply out, root 6 minus root 2 over 4. This is 4. Common denominators, I add them, get them common. Multiply the tops. Oh, same answer? No, this is root 2 minus root 6 over 4. This is root 6 minus root 2 over 4. Okay? Alright, you can type this in later. Number 3 is just no-brainer. Okay, you may, don't do this, but you may compute this individually and get the answer, but that's not how I want you to do it. You can compute each and every one of these, multiply and subtract. Don't do that way, because this looks like an expansion, one of the expansions on the table. Which one? Cos, cos, sine, sine. Where do you see cos, cos, sine, sine? It's the one just we did, right? Cos, cos, sine, sine with a minus in between. All you need to do is figure U and V. What is it? What is U and V here? That's it. Now add these up. This is 60. This is what, 150? And you add them, they make 210. What is cosine 210? This has 210 as a what is it called? Reference angle. What's the reference angle of 210? Here is 210. What is the reference angle? Shortest distance to the x-axis. 30. So this is equal to cosine 30, except you need to pick the right sign. Is it positive or negative? On third quadrant, cosine is cosine in third quadrant negative. It's x coordinate. X coordinate of a point in third quadrant is negative. So it's cosine pi over 6 with a negative. Or get the wheel. You remember that we had the wheel of values all written? Just read the x coordinate of this point, but I don't have it. I just go with the reference angle. Now what is cosine 30 again? Root 3 over 2. It's negative root 3 over 2 it is. So 210 has reference angle of 30. I just turned it into pi over 6 and compute it. Any questions? Alright, we haven't done anything with tangent yet. We have a couple more until there. So far we've been using sine and cosine. Okay, what is the deal here? Please read the question. They are asking a difference of two angles, but we don't have any clue what those two angles are. They have given us its sine of alpha, cosine of beta, and that's it. And they have also provided us which quadrant they are. Alright, what do I need to know to get sine alpha minus beta? Let's expand this first. Sine alpha minus beta is, just think this as alpha and betas, right? Is sine alpha cosine beta cosine alpha sine beta. Agree? Do you agree? Now I need to know just four things will be done. But do you know all four? We know sine alpha, right? This is known. Do we know cosine beta? Yes, we do. Here. Do we know cosine alpha? No, we don't. We don't know yet. Do we know sine beta? We don't know yet either. Oh my god, how do I get those two question marks? Because I know the first half. Sine alpha is 11 over 12. Cosine beta is 15 over 17. I wish they have provided us these so it could be done in a second. But no, they just want to make our life harder. What do you think? Once I need to know cosine alpha, they have provided us sine alpha. If I know sine, how do I get cosine? Do we have an equation between sine and cosine? I can use sine value to get the cosine. I believe in our toolbox there is a formula for that. Right? Right? What is it called? Pythagorean identity. Sine square plus cosine square is 1. So sine square alpha, cosine square alpha should also make 1. Don't we know sine alpha? Yep, we do. It's 11 square over 12 square. We don't know cosine square. I will get to that. So cosine square is 1 minus 11 square over, what is 11 square by the way? 12 square. Okay, let's get common denominators here. I multiply both sides 144, subtract 121, what's left? 44, 21, 23 over 144. That's cosine square. I need to get cosine. What shall we do? Take a square root and cosine alpha is root 23 over 12. I can take 144 as 12 out, but it's in the denominator, so it will stay in the denominator. Okay? Am I doing right? I will go ahead and replace here root 23 over 12. Do you agree? Why don't you? Why don't you agree with me? Madison? Or Maddie? You don't know? Something smells fishy here. Because they have provided these as, and I haven't used them. What the heck these two mean? Alpha is in quadrant 2. Quadrant 2 angles are like this, right? This is unit circle. So you have an angle here. This is your alpha. For a quadrant 2 angle alpha, what is x coordinate of it? Isn't x coordinate negative? Isn't x coordinate is cosine value of it? How come I have a positive number here? It's supposed to be negative. Where did I mess up here? Where is my mistake? Here is your mistake. When you take in an equation solving question, square root of both sides, you need to put plus minus. So there are multiple answers for cosine. It can be plus or minus. You must pick the right choice. Which choice you're gonna go with. That's why they have provided us this. In quadrant 2, cosine alpha is negative. It's given negative. I need to go with negative option here. Okay? Makes sense? Remember the sign chart of cosine, cosine given? From there, cosine is negative in quadrant 2. How do I get cosine beta? You don't agree with me, Kylie. What's wrong? Again, when you take square root of both sides, there are always two answers, plus and minus. We need to pick one. To pick one, I need extra data, and they have given us here. That angle alpha is in quadrant 2. In quadrant 2, cosine is negative. Okay? Okay? Sine beta. Let's do the same exact work for beta now. This time we know cosine square beta, which is square of this thing. Subtract from both sides. $289 is square of 17, right? Alright, this is 289 over 289. Subtract 225. What is it? 64. Am I right? So this time we have a better value. 8 over 17. Square root of 64 is 8. 289 is 17. Is this the right answer? Is this right? So I will put 8 over 17 then. Yes. Again, I did the same mistake. This is plus or minus when you take square root. And I need to pick one. Why did you go with negative then? Why not positive? In quadrant 4, here, this is your beta. Any angle in quadrant 4 has sine value negative. Right? Y value is sine. It's negative, so this has to be negative. Alright. You have one negative, one negative, one negative, triple negative multiplying. What is the result? It's negative again. 8 root 23 over 204. Am I right? 12 times 17 is that? I don't like the numbers. Maybe I made a mistake somewhere. Double check. hope. But this is it, I believe. Well, there is one way to learn it. Which question was that? Number 4? Yeah. 165 minus square root what? And 304. Yeah, that's correct. Bad numbers, but we did it right. Okay, we're almost halfway through. We're gonna continue this on Friday.